Okay, so the advantages of pulse closing come from the fact that it uses 95% less energy than reclosing to test the line for the presence of a fault. Therefore, it is perfectly fine to set up a test sequence for underground circuits, and it will automatically restore service to underground or mixed networks within seconds in the case of a transient fault. If the fault is sustained, the device will lock out after a few quick tests. The ability to detect the presence of a fault without putting the full fault on the system is the largest breakthrough in reclosing, which has been a common practice on utility distribution systems for more than 70 years now. The ability to use overhead distribution protection techniques on underground sections or mixed feeders gives the protection engineer more flexibility for protecting feeders, especially those mixed feeders. And by avoiding the fault multiplier effect of reclosing, this essentially causes the number of faults seen by distribution equipment to decrease, which means less damage to repair and longer asset life. And the last topic I want to touch on is that the devices with pulse closing technology can be used standalone, but there's even more benefit when they are applied as a team. And so we'll have a quick example. Say we take a very simplistic representation of two distribution feeders that are tied together by an open point. It doesn't actually matter if these are overhead, underground, or mixed circuits, but let's say these are two underground feeders and the blue and orange dots are ring main units. A fault anywhere on the blue feeder is going to trip the breaker and cause an outage for the entire blue feeder. When the crew is on site performing switching actions to isolate the fault and restore service to partial customers, then can close the open tie switch to serve some of the load from the orange feeder. This is a typical operation of a non-automated underground distribution system today. But one application example of pulse closing on underground feeders is to take 3 or more pulse closing units and placing them mid-feeder and one at the tie point. These 3 or more devices can be overlaid on top of an existing system and require no changes to the existing breaker settings, and it doesn't interfere with the ring main unit operations. When a fault occurs, the pulse closing devices interrupt, isolate, and restore within seconds, thereby avoiding customer interruptions, customer minutes lost, and even avoiding short interruptions for about half the customers. The pulse closer in the middle has taken the place of the normally open switch in the first diagram. In fact, this device could be operated as a normally open point, and it can be configured with loop restoration settings, so when it detects the loss of supply on one side, it can wait a few seconds and then pulse to test the line to see if the fault remains, or if it's safe to close and restore some of the load to the adjacent feeder. One nice effect here is that you'll never see the fault current on the other feeder, so there's no voltage sags for the otherwise unfaulted feeder. And for a slightly more advanced application, this again can be overhead or underground or mixed. All 3 of the pulse closers could be operated in a meshed system where all 3 of them are closed, since these devices allow for protection settings in both directions.